The GVSU Formula Racing team has sponsored the project of an engine dynamometer. This project was designed by a team of 6 senior engineering students: John Santos, Noah Bolo, Alex Broick, Zachary DeVos, David Dragowski, and Austin Beardsley. The advisor for this project is Dr. Bain. The FSAE team builds a Formula car each year and races it in an international competition. Historically, the team has struggled to quantitatively assess engine performance and was only able to test the engine during a limited time window. This dynamometer will allow the team to test the engine during a longer period of time and optimize more engine parameters. An engine dynamometer, commonly referred to as an engine dyno, is a machine which measures power output of an engine. The dyno is designed to apply a load to the engine at various RPM and measure the resulting force output. We opted for the eddy brake dyno design. In this design, as shown in the diagram, the engine is coupled to an induction disc. When the engine is running, the disc spins at the same RPM as the engine. The coils, shown on either side of the disc, apply a magnetic field into the rotating disc, which causes the disc to resist rotation. The strain gauge attached to the coil casing will allow for an accurate reading of the force being produced by the engine. This dyno type was chosen because of its ability to hold a steady force over a wide RPM range, the ability to instantaneously change the resistive force, and the lower price point when compared to an electric motor dyno. Once completed, the GVSU Formula Racing team will use their engine dyno to adjust engine settings and determine the effect of such changes on engine performance. Initially, the engine will be installed as shown. Then, a protective cage will be attached for user safety. Once everything is connected, the user will operate the dynamometer from the rear of the cart. Here they will have access to mechanical engine controls and a USB plug-in to connect their laptop to onboard electronics. This dynamometer should be capable of taking measurements up to 140 pound-feet of torque and 100 horsepower at the output shaft while meeting predetermined accuracy and precision requirements for the measurements taken. It should be capable of testing a variety of engines which fit within a 24-inch cube, and once the engine is connected, should only require one person to operate. While developing the dynamometer, a gear ratio was set in order to keep the eddy brake under its RPM limit. Additionally, adjustable engine mounts were used in order to allow the design to accommodate different engines, and the upper portions of the assembly are connected using rubber inserts to mitigate vibrations. Due to the coronavirus outbreak, we were unable to build the dyno. In lieu of building the dyno, the design was analyzed for its stress and heat responses during operation. Additionally, a step-by-step document was created to enable the Formula team to perform the build after restrictions have been lifted. While we were unable to build the assembly, the simulations performed show that the design will meet or exceed all critical criteria. Thank you for watching, and we look forward to your questions during the live session on Design Day.